So, yeah, good evening, Ramchandra. Last class we have completed stack operations using list concept and queue operations using a list concept. Today I would like to explain a linked list concept. Before going to our program, let me again remind the linked list concept, how linked lists is going to help us to develop real-time applications. Why we are using a linked list? In order to avoid the drawbacks of arrays. What are the drawbacks of arrays? Do you have any idea? I'm asking a simple question.
If it is a static array, we will have only, let's say, the
Arrays.
defined number of values.
Yes, perfect answer. Yes. Any other answers? Why we are going for linked list?
Because linked list we can keep extending the number of nodes and
perfect.
Yes.
Is there any other? I'm expecting more answers from you.
Okay.
It is quite good. There are plenty of drawbacks in arrays, you know.
Okay, sir.
Plenty of drawbacks. Like, do you have any idea? Can you extend your knowledge? Whatever you have explained, that is correct. Okay. So arrays are fixed size, you know.
Yes, sir.
Very good answer. Array stores only same type of elements. Okay.
Yes, sir.
It cannot hold multiple data types. So that is one drawback. Fixed size, one drawback. Memory wastage, one drawback. Insertion deletion is a very difficult in arrays. You know,
yes,
between A of 0 to A of 1, if you want to insert or delete, it is very tough to. So many shift operations are required to insert element between A of 0 to A of 1. Whereas in linked list, it is very easy to insert element and delete element very easily based on the reference concept. And high memory wastage in array. Suppose you have declared int A of 100, but you are using only 10 elements. What about remaining 90 elements, Ramchan?
Yeah, it goes unused.
Yes, it's a memory wastage. That's why we are going to use linked list concept in order to avoid the arrays concept. So linked list, how easily you can define linked list is nothing but linked list is a collection of nodes and connected by the links, okay, in any order. That is called a linked list. In order to avoid the drawbacks of arrays, we are using linked list concept. So now there are three types of linked list. Collection of nodes and connected by the links in one direction is called single linked list. Okay. So next one is a collection of nodes and connected by the links in both directions. That is called a doubly linked list. Collection of nodes and connected by the links, the last node is connected to the first node, is called circular linked list. Perfect. Write a Python program to perform list operations such as insertion, means we are adding element into the existing list. Deletion, we are deleting element in the list. What is meant by list? List is a collection of items. What is linked list? Collection of items connected by the links based on the reference. Then searching, we are searching element in a list. Then we are displaying elements in the list using single linked list we are going to perform today. Ramchan, yes, that sir. Is okay?
Yes, sir.
Okay. Now, I am going to explain the program, then I am going to demonstrate. So my class name is a node. Can I ask a simple question?
Yes, sir.
What is node? What is node? How can you define node?
I mean, here the name of the class is node, and in a node we can have an element, and elements can be connected with the links to the next node.
Perfect. You need to say like this. Node is a combination of value and address. That is called a node. Okay?
Okay, sir.
Node is a combination of value and address. Now, I am declaring the function init function. It's for initialization for we used to call initialization purpose we are using init function. Okay, constructor, you know constructor?
Yes, sir.
So for initialization purpose we are using, there are many constructors are there. Copy constructor, okay.
Yes, sir.
So here, yeah, class name is a linked list, and again definition init function, and definition of insert at the end. So I'm going to demonstrate right now. 1 second. So my program is SLL program. See here, CMD. So CLS, clear the screen. My file name is notepad say space SLL program dot py. Py is the extension of a Python programming. Singly linked list program I am going to demonstrate right now. Write a Python program to perform linked list operations such as insertion, deletion, searching, sorting. Okay, so so we are using so many operations. Okay, so many operations we are using, like insertion, deletion, display. Okay, and we are using many operations which are available in even arrays also. Now my class name is a node. So whenever you are going to start a node, capital N must be there. Then function name is a init underscore underscore. That is, it is a mandatory. Self means automatically whenever you are calling any function, automatically it initializes whatever the value is there. Self comma data colon is a function. That is a syntax. Self dot data equal to data. Suppose 10 element I am inserting. So data becomes 10. Okay. Self dot next means next element is none. That means no element is there. Next class linked list. Definition is init self dot head node initially none. So wherever you are using none, it must be a n must be a capital letter. Okay. Then definition insert at the end self comma data. New node. I'm adding new node equal to node of data. Node is my class name. With that one, I'm inserting element data. If self dot head is none, then we are going to assign new node. Self dot head equal to new underscore node. Else temp equal to self dot head, while temp dot next colon temp is equal to temp dot next. That is next element we are inserting. So we are keeping in the third element called temporary. Temp dot next equal to new node. Print. F means formatted printf statement. F double quotation start. Inserted data at the end. Next, delete function. What we are doing? Define delete underscore node self comma key colon temp is equal to self dot head. Next, suppose if you would like to delete element in a linked list, we need to use the procedure like this in this function. If a head node itself holds the key, if temp is not none, then we are performing next operation like if temp dot data exactly equal to key, whatever the element if you want to delete. So suppose key is 10, then self dot head equal to temp dot next. Temp is equal to none. Print deleted node with the value of key return. Then search for the queue. Next searching operation. How to do? Search for the key to be deleted. That is in command line, comment section. So previous, PREV, previous equal to none. Suppose there is no element from if you start with head node. While temp is not none and temp dot data not equal to key, in that condition, then previous is equal to temp. We are assigning the temporary variable. Then temp equal to temp dot next. So if the searching element in the head node, if it is not there, then we are going for next, temp dot next. That is in searching position. Then if next comment, if key was not present, then what you have to do? If temp is none, print f node with value not found. Suppose the searching element is not there, then it will display the node is not found. I mean, element key value not found, return. Next, unlike the node from linked list, previous dot next equal to temp dot next, temp equal to none. Deleted node with value. Which element you have deleted, it can display. Next, search. Definite search, I mean definition search of self comma key. What you are doing searching? Temp is equal to self dot head while temp colon. If temp dot data is exactly equal to key colon, print node with value key found, return true. Temp equal to temp dot next. So node next we are printing that element node with the value not found, return false. Then we are displaying elements like how many elements we have inserted, suppose 10, 20, 30. How it is going to help us? Definition, display self means automatically. Whenever you are calling the class object, automatically it can initialize with a constructor called a self. Temp equal to self dot head. It starts with the head element. If temp is none, it will print linked list is empty. Return. If suppose we have inserted 3 elements, print linked list elements are up to end. The last element also it will print. While temp, print temp dot data, comma end equal to arrow mark. 10 arrow, 20 arrow, 30 arrow, like that. Temp is equal to temp dot next, print none. Suppose last element is next in, it will print. Example, it says like if underscore underscore name underscore underscore, it is a variable exactly equal to underscore underscore main underscore underscore. Why I am declaring in the name, it starts with the main function. That's why that means class node. Linked list equal to LL. This is LL. LL means linked list. My file name, my class name is a linked list. I am creating an object called LL. LL is an object. Object is a physical instance of a class. It can access functions task. LL dot insert at the end. I'm inserting 10. LL dot insert at the end 20. LL dot insert at the end 30. 10, 20, 30, three elements I have inserted successfully. LL dot display, it can display, it will call the function, then it will print all the 10, 20, 30. Then LL dot search. Suppose you are searching for 20. So it will display the searching element is 20. Then if you want to delete 20, LL dot delete underscore not 20. After display, it will print only 10, 30. The search element is 20, it will print search. Okay. Now I am going to execute this program. Any doubt, Ramchan? It's okay?
Okay, sir.
Now I am executing this program, Python space SLL program. Okay. So now inserted element is first 10 at the end. Yes. Inserted 20 at the end. Inserted 30 at the end. Now it will display the three elements. Linked list elements are like 10, arrow 20, arrow 30. And the last element is none. Node with value 20 found. We are searching 20 element. We are deleting element, node with value is 20. After 20 deleted, what are the elements are remaining? Linked list elements are 10, 30, none. Node with value 20 not found. After deleting, if you are searching 20, it cannot print. So this is the way we are executing linked list program. So can you execute this program, Ramchandran, right now?
Yes, sir.
Hello.
Yes,
Yeah,
sir.
please open. Yeah, you can share your screen. So we will execute this program. Where is your screen? Can you share your screen? So 1 second. Yeah, you have shared your screen. Yeah, you can share your screen and let me. Yeah, now, yeah, write a Python program to perform linked list operations such as insertion, comma, deletion, comma, searching, comma, and display using a single linked list. Using a single linked list. Next, enter. Deletion, comma, searching, and display using single linked list. Display using single linked list. Full stop. Single linked list. In the bracket, you can write SLL. SLL. Single linked list. Enter. Class name is a node. Class space node. N must be capital. Colon. Def space underscore init underscore parenthesis begin self comma data parenthesis close semicolon end.
Yes, sir.
No, semicolon, sorry, colon unit end with, because it is a function. Self dot data equal to data. Self dot data equal to data. Enter. Self dot next equal to none. Self dot next equal to none. N must be capital because it is a keyword. Enter. Next subclass name is class. Wherever class node started, there itself. Class space linked list. Linked list is a single word. L capital. L in the list also L capital. Linked list colon. Enter. Yeah. Def space underscore init underscore parenthesis begin self parenthesis close colon. Enter. Self dot head equal to none. Yes, enter. Again, next function. Below definition init, one more function. Yeah. Def space insert underscore at underscore end. It's a function name. Parenthesis begin self comma data. Self comma data. Parenthesis close colon. New underscore node. No. Small n. New underscore node. New underscore node equal to node of data. Node, capital N. Node. Node of data. Parenthesis begin data. Small data. Parenthesis close. Enter. If. No, not below in new node only. Yes. If space self dot head space is none. If space self dot head is none space capital N colon enter space tab space. Yeah, perfect. Self dot head equal to new underscore node. Small n only. New underscore node. Enter. Below if you need to write else colon enter tab space. Yes, perfect. Temp equal to self dot head enter while. Yes, perfect. While space temp dot next colon enter colon. enter, you can use tab while again one more tab. Yes, perfect. Temp is equal to temp dot next. Temp is equal to temp dot next. Enter. Below while you can write temp dot next. Yes, perfect. Temp dot next equal to new underscore node, enter. Below else you can write print statement. Print parenthesis begin F. F indicates form feed actually. Double quotes begin inserted space flower brace begin data, flower brace close, flower brace curly brace, yes, data. Then at the end, at the at the end double quotes closes, parenthesis close, enter. Now next function under below definition you can start. Yes, perfect. Def space delete underscore node. Now we need to write delete, not deleted, delete. Yes, underscore node, parenthesis, small n only, node, underscore node, parenthesis begin self, comma, key. Self, comma, key. Parenthesis close, colon close, enter. Temp equal to self dot head. Temp equal to self dot head. Enter. You can write comment section hash. No, there itself. Starting. Hash. If a head node itself holds the key. If head node itself holds the key. If head node itself, you can remove it. If head node itself holds the key. Enter. Now under below temp, you can write tab. You can use, yes. If temp space is not none, temp is not none, capital N, none means capital N, colon, enter, one tab space again, if under, enter, yes, self dot head equal to, 1 minute, where you are written, if temp is, okay, temp dot data, sorry, you can just remove that one. No. If in the if statement, again if statement, that is correct. That statement is correct. Below you can remove. There itself, you just remove the entire thing. You start with the if space temp dot data exactly equal to double equal to key key colon enter. You just use tab symbol below. Yes, self dot head equal to temp dot next. Self dot head equal to temp dot next. Enter. Temp equal to, yes, temp equal to none. Capital N, none. Enter. Print. Below temp only, you just write down. Print. Parenthesis begin. F double quotes begin. Deleted node with value. Deleted node with value space flower brace begin key flower brace close double quotes closes parenthesis close, perfect. Now enter. Now you need to write below if temp in that yes there, or you can start with the starting hash comment section, write down search for the key to be deleted. Search for the key to be deleted. Key to be deleted, enter. Now you can use, yes, from there only you can start prev, P-R-E-V, prev, 1 second, where you have deleted keys, 1 second. Return you need to write after printf statement. Yes. There you can write a return. No. Print below. Yes. Now come to previous. Previous equal to none. That is correct. None, capital N must be there. Then, okay. Now, under below prev, you can write while space temp is not none, while temp is not none, none means capital N, none, and temp dot data space temp dot data not equal to key colon enter use prev equal to temp enter temp equal to temp dot next under while you can write just go to starting page, write down comment section if key was not present, if key was not present, if key was not present, enter. Below while you can write if statement, if temp is none, capital N, none, colon, enter. Print statement write down. Print, parenthesis begin, F, small f, double quotes begin, node with value, flower brace begin, key, flower brace close, space not found, double quotes closes, parenthesis close, enter, return, under print, yes. Next comment section, write down, comment section, hash, unlink the node from linked list. Node from linked list. Enter. You can use under if, yes. There you write down prev dot next. Prev dot next equal to temp dot next. Enter. Temp is equal to none. Temp equal to none. Capital N. Perfect. Below statement print. Print parenthesis begin F. Double quotes begin. Deleted node with value. Deleted node with value. Space flower brace begin key. Flower brace closes. Double quotes closes. Parenthesis close. Perfect. Next function. Under definition only you need to write where delete function you have used. Def delete, same position you can use. Perfect. Def search. Now you need to use def search. Parenthesis begin self comma key. Self comma key. Parenthesis close. Colon. Enter. One tab space. Yeah, perfect. Temp is equal to self dot head. Temp equal to self dot head. Enter. While yes. No. Under temp only while. While space temp colon. Enter. Now you can use one more tab. Yes, perfect. If temp dot data exactly equal to key colon key key colon enter. Now you just use a tab space. Yes, perfect. Print parenthesis begin F double quotes begin node with value space flower brace begin key flower brace closes space found found double quotes closes parenthesis close. Perfect. Enter. So below that return true. Written. No, below print only. No. Yes, written true.
Yes, sir.
Whenever
Yes.
you are using true, you need to use capital letter T. True and false. In Python. Next, below if statement write down. Yes. Temp temp is equal to temp dot temp dot temp dot next. Enter. Under while statement, you write printf statement. Print parenthesis begin F double quotes begin. No, yes. Parenthesis begin yes. Node with value. Node with value. Flower brace begin. Key flower brace closes. Not found. Space not found. Parenthesis close. Return false. Write down below print statement. Return space false. Capital F. Yes. No. Under print only. Yes. Return space false. Capital F. Enter. So now one more function. Def display. Last function. Def space display. Parenthesis begin self. Parenthesis begin self. Self only. It is a constructor. Parenthesis close colon. Enter. Now one tab space. Yes. Temp equal to self dot head. It starts with head. Self dot head. Enter. If if yes, there
Sir, here
only.
colon only,
If
no?
space temp is none. Temp is none. Capital N colon. Enter. Now use print statement. Enter. Use yes, none colon. Yes, perfect. Now one more tab. Yes. Print parenthesis begin, double quotes begin, linked list is empty. Write down linked list is empty. Double quotes closes, parenthesis close, enter. Now return. Under print you can write return. Yes. Now under if statement you write down print. Print parenthesis begin, double quotes begin, parenthesis begin, double quotes begin, linked list elements. Linked list elements colon double quotes closes parenthesis double quotes closes comma after comma end equal to end equal to double quotes begin space double quotes closes. Yes, there only one. Yes, parenthesis close, enter. While under print statement you can write while. Yes, while space temp colon. Why you have given one more line there? You just bring it above. Yes. While space temp. Now you need to use tab space. Yes, one more tab. Print parenthesis begin. Temp dot data. Temp dot data, comma temp temp comma end comma end equal to double quotes begin arrow mark. Double quotes begin arrow mark. 2 times. Okay, no problem. Double quotes closes. Parenthesis close. Enter. Under print statement, that is correct only. Enter. Temp equal to, there. Temp equal to temp dot next. Temp dot next. Enter. Under while you write print statement. Print, parenthesis begin, double quotes begin, none, capital N. None. Double quotes closes, parenthesis close. Now enter. Starting you can write hash example usage. You can write example usage. Enter. Now you need to write if starting. You don't give space there. You just go up one line space. Okay, if you give, no problem. If space underscore name underscore equal space exactly equal to, yes, double equal to space double quotes begin underscore underscore main, main, underscore underscore double quotes closes colon. Enter. Now give one tab space. ll dot ll is equal to, sorry, not dot, ll is equal to link list. L must be capital, list, linked list, lin, yes, list, parenthesis begin, parenthesis close. It is a function now. Enter. Same under below ll, you can write ll dot insert underscore ll dot insert underscore at underscore end at underscore end end within the bracket 10. Now like that 20 30 you can insert, same thing. Then ll dot display, next function, ll dot display, ll dot display, parenthesis begin, parenthesis close. Enter. ll dot search of 20. Enter. ll dot search of 20. Enter. ll dot delete underscore node. ll dot delete underscore node of 20. Enter. ll dot display. Display. Next, last statement, ll dot search of 20. Yes, save the program. Now run the program.
82, sir.
Python space sll dot, no, Python space.
ll
Yes.
dot delete.
So line number?
Underscore node of 20.
What is the problem? Delete underscore. ll dot delete underscore node. Correct.
Yes, sir.
In the delete function, what you have written?
Instead of L, I have typed as capital I. Yeah.
What is the error? What is the error?
Yes,
I didn't.
Yeah. Yes, sir. Yes, sir.
Oh, very good, very good. This is called linked list. Very big programs. It takes time for you to understand. Okay. So many functions we have used. You understood now how to write Python. Okay. Now we are moving to next concept. Okay. So with this one, I'm closing this theory part. Now we are going to solve the concept like.
Okay. So are you sharing your screen, sir?
Which of the following is not a type of data structures?
Yes, sir.
Any answer from your side? Try. Now I'll give you a complete scenario. What is, oh, sorry, one
Yes,
second. Sorry. I forgot
yes, sir. It is
actually.
visible. Which of the following is not a type of data structure?
Resume. Okay.
Function.
Now my screen is visible.
Because stack and queue are data structures because they store data, and array can also store the elements of data structure. But function is to run these data structures.
Why? Can you justify?
Okay, sir. Yes, sir.
Perfect answer. Function. Next question.
Okay, sir.
So how can you define array? Array is a collection of homogeneous elements and shared by a common name.
Size.
Okay.
Yeah.
Simply you can say array is a collection of same type of elements stored under the single name.
First,
okay. A of 10. What is meant by A of 10?
Function.
A is array name. 10 is a size of the index.
Instructions.
Okay,
to
like that.
execute
What
an
is
operation.
stack? Stack is a linear data structures and follows the principle last in, first out. What is function?
Okay,
Yeah,
sir.
what is function? Perfect.
Okay, sir.
Function is a set of rules to perform specific task.
Functions.
Function is a self-contained block of statements to perform specific task. Okay. Functions are two types, predefined functions, user-defined functions. Predefined functions are defined by the software itself in the software. User defined functions are defined by the user. Example like CLR, SCR, get ch, sqrt. These are the
Pushing an
user
element is a
defined, big,
operation of the
small,
stack,
towers of an eye,
and then
like that.
deleting an element is
Now,
pop
which operation
from
is
the stack,
not applicable
and
on a
peak is
stack?
the
What is
top
stack? You need to know.
element of the stack.
Tell me.
Whereas yes, and
Yeah.
search is to search an element.
Perfect.
I think peak.
Without moving, we are deleting element. Peak. Mm. Now, which operation is not
Okay.
applicable on a stack?
Okay. Okay, sir.
Actually,
Okay.
yeah,
Okay.
it's okay. Actually, four options are applicable, but the minor difference. And main operations are three: push, pop, pick. Search
Okay.
is general term.
Sir,
Okay,
actually,
search is a general term.
priority queue
Okay, next
is
question.
there.
Which of the
Yeah.
following is a type of queue?
And
Now
then
tell me.
LIFO is actually last in first out, which is stack, no, sir. Both is
Is a
not the
type of queue.
answer.
Yes, it is a type of a queue.
Yeah. Yeah, priority
Perfect.
queue.
Next.
Yeah, that's what I was thinking. Yeah.
Which of the following is a type of queue? Only one you have to answer. Priority queue. Remaining all are wrong answers, na?
Yes, sir.
Yeah.
No, sir.
So next question. You know what is meant by priority queue? Yeah, no problem. Priority queue is a queue, follows the principle is best in first out before, not
Okay, sir.
before, first in first out. Before, suppose you got state first rank in Tamil Nadu, okay, out of 1 lakh students, you are the
Yes,
first
sir.
person before, best in first out. In that case only it can work. Priority, I'm giving priority for you because you got a very good percentile, 99.99.
Okay. In
Are
a
you
double linked
understanding
list,
what I'm
each
saying?
node contains
So that's why
data and one pointer.
that is
No,
called
it should be data with two pointers. Answer is
priority queue. Next question.
B, sir.
Tell me next question.
B. Answer is B. B. Yeah, because it's a doubly linked list, so it should have two
In a
pointers.
list, each
One
node
pointing to the next,
contains.
one pointing to the
Correct.
previous one, and then data will be in
Answer
between.
is B. That is perfect answer. Why? Can you justify your answer?
A node can have at most how many children? Binary tree. At most two children, sir.
Perfect answer. Perfect answer.
In
Next
binary
question.
tree, a node.
In a binary tree,
Most, yeah. Yeah, binary tree.
sorry?
Yes,
Yeah.
sir. It's a type of
In
tree
a
where
binary
it
tree, a
can
node can
contain
have at
many number of
most two.
elements,
How
and
many?
we can
Perfect,
divide the tree by
perfect
2,
answer.
and then we can
What is binary
search
tree?
the
Can you
element.
define?
I
A
mean,
type of
based on
tree.
the middle value, we can start searching the element. If the middle value, I mean, if the searching element is less than the middle value, then we can search on the left side of the tree. If the searching element is greater than the middle element, we can search from the right side of the tree. So we can continue this process till we find the element.
Okay. Perfect.
Okay.
Perfect. Which of the following hash table collision resolution techniques uses a linked list to store collide keys? We have actually one concept called hash table. I have
Okay, sir.
explained to you. Hashing is a process of key with value, and if collision means two elements are competing at the same bucket, same location. That situation is called collision. Sometimes to avoid that collision, we are using collision resolution techniques like open addressing and quadratic probing, double hashing, separate chaining. So, which are the following hash table collision resolution techniques use linked list to store collide keys?
Okay, sir.
Whenever two elements are competing in same place, we are using separate chaining address. Chaining means reference, like previous and next node. In
Linear
doubly
which
linked
is
list, we are using two
order of
nodes.
n.
I mean, two reference points. Like separate chaining is a one more technique. Next, what is the time complexity of linear search? Tell me.
Uh,
Perfect,
I think
perfect.
sorted, sir.
That is perfect answer. Correct. Next, binary search requires that the array could be binary search requires.
Not still.
Yeah,
Yes, sir.
perfect answer. Perfect answer. Binary search. Next, which of the following algorithm is not stable? We have a bubble sort is a exchange sort. Insertion sort is nothing but we are inserting elements, but
Yes, sir. Okay,
we
sir.
are following some rule.
Okay,
Quick
okay,
sort
sir.
means quickly we are achieving the result, I with the pivot, j with the pivot. So not stable means quick sort, remaining all
Function
are
sort
stable.
is
Okay, because with the pivot and right side with the pivot. Next, 10th
okay, sir.
element,
Okay,
10th
sir.
question. What is the time complexity of selection sort?
Divide and conquer, sir. Divide and
Order
conquer.
of, yeah. So it takes time for mathematical calculation, order of n square. Okay. Keep next. Merge sort uses which technique, which approach? We have divide and conquer. Divide and conquer. Very good answer. Because we have four approaches in
Yes, sir.
data structures. Dynamic programming, under that we are saving the
Okay, sir.
time and memory and everything. Under dynamic programming, we are solving the knapsack problem. 0 by 1 knapsack problem. Gold coins we are keeping in the sack. Then greedy approach also same problem we can use. Greedy dynamic programming, under that we can use a shortest path, a traveling salesman problem, etc. Then divide and conquer, we are using merge sort and quick sort. The very big problem we are dividing into sub problems. Each sub problem we need
Yes,
to
sir. Yes, sir.
arrange in order, then we are following. Backtracking is a one more approach in data structures we are using in n queens problem. N queens
Dynamic.
or chess
Okay.
problem.
Divide
Backtracking.
and conquer, backtracking.
So those examples comes under backtracking. What are the four approaches? Dynamic programming, greedy approach, divide and conquer, uh, backtracking.
Graph
Yeah,
with
whatever
more
the
cycles
concepts
is
not covered
called
in the syllabus while explaining a previous
one
class, I'm
cycle. That
covering
is
now. That's why you can
subgraph.
listen carefully. So divide and conquer is the correct answer.
Ah,
Next question.
yeah. Yes, sir.
Yes.
I think it's D.
So cycle means what? Tell me.
Subgraph.
All the nodes are connected. All the nodes are connected. Okay.
Connected. Yes, sir.
So then
Oh, okay.
no
Okay. Acyclic
cycles.
is not connected.
No,
Okay, sir. Okay,
think
sir.
what is meant by complete graph? All the nodes are
Okay.
connected. What is
Okay, sir.
acyclic graph? Acyclic means opposite. What is simple
Okay,
graph?
sir.
What is simple graph? What is
Okay, sir.
subgraph? Subgraph, simple graph,
Yes,
complete
yes.
graph are connected each other. Okay. Acyclic graph not like that. This is the opposite of complete graph.
Which graph
Not
traversal
connected.
algorithm
Some
can be
nodes are
used
not
to find
connected.
the shortest
Acyclic
path
graph.
in an
You understood?
unweighted graph?
Perfect.
Graph
Next question.
traversal.
Tell me the answer. Read and loudly you can read and tell me the answer.
Sir, actually, the DFS is like stacks, sir. BFS is like queues.
Yes.
Is it true?
Mm.
Depth first
Graph
search is
travels
like
are too important.
queue.
I have
Breadth first
explained
search is like
already.
stack.
Depth,
Okay.
huh? Shortest path.
Queue, yeah.
Unweighted graph. Yeah. Try.
Yeah, first in,
Your
first
answer
out.
is quite good. Okay. So breadth
Stack
first search uses. You know what is
LIFO.
the
Sir,
principle of
yeah.
data structures in breadth first search? Q. What is the principle of Q?
Time complexity of
First in
BFS.
first.
BFS is,
Perfect answer. What is depth
sir,
first
I
search?
don't know this
It
answer. What
uses
is
which
B and
data
E, sir?
structure
Sorry.
stack? Perfect. Last first out. Very good
Okay.
answer.
Okay,
Next
okay.
question.
Vertex and
Tell
edges.
me.
Edges, no? E is edges. So I think the answer is D.
Vertex.
Oh,
In the graph, we used vertex,
okay.
nothing but node.
Edges. Okay, sir.
Correct. Perfect answer.
Yeah.
Order of
Okay.
V, order of V plus E.
Okay, sir.
Both
Okay, sir.
you need to add. Vertex plus edges. Node plus arcs. Node plus arcs. You know, node plus arc. Arrow
Most
mark. We
recursive
are
is,
connecting with one node to another node. Okay? Okay.
is it,
You just remember, very important
it cannot
subject this
be
is.
data structure. It
Next,
cannot be
what is
empty
the
data
base
structure. That
condition
is
for
wrong.
most recursive algorithm?
Boolean is only a function calling itself again and again.
What is the base condition for most recursive algorithms? Yes. Try. What is meant
Um,
by recursion? What is meant by recursion? First tell me. So that perfect answer. Ramchand, you are so
yes.
good while answering this question. Give examples for recursion
Okay.
where we used to call this recursion. So many times we are
Yeah.
calling itself.
Yes.
Okay. Suppose under main you are writing main function. Under main you are writing main function. What will happen?
Yes,
Main
sir.
is calling many times. It is going to infinite loop. You know,
Fixed
recursion.
value. Oh,
System
I was
feels
thinking the answer
very
has come.
risky,
I
risky,
think the
risky.
same.
So
Yeah, I think
don't
the same.
use always
Yeah.
recursion. It's very risky. Okay. So what is the base condition for most recursive algorithms uses if it
Wait, sir, I'll tell this.
arrays constant.
Is
In
it
arrays it
linked list?
used to. Yeah, perfect. Next, which data structures can be used to implement both
Yeah,
stack and
because
queue?
stack is last in first out,
Yeah,
whereas queue is in first out.
try.
So single linked list, single linked list,
Think over.
both
Yes,
concept can be
perfect answer.
implemented
Yes.
using
Why?
single linked
Can you
list
justify your
because,
answer?
yeah,
Yes. Both concepts can be implemented.
1 minute, sir. Parsing expressions.
Perfect. Perfect answer.
I
Next
think,
question.
yeah, I think
Which
when you
of
were
the
explaining,
following
as
is
you
an
told me, I
application of
remember.
stack? Parsing
Okay, sir, correct. All
expressions.
of the
Why?
above, all of the above, correct.
Can you justify? No, but why only parsing expression? Even job scheduling also uses
Okay, sir.
LIFO.
Okay,
Even
sir.
network routing also uses LIFO. Think.
Okay, sir.
Very good answer. Usually, all of the answer is
Yeah,
correct
that's
answer,
Q. Yeah.
stack principle. Okay, both answer, but specifically it is asking, you
Yes,
can
sir.
go for parsing.
Yes, sir.
But even job scheduling uses first in first
First out,
out, I
yes.
guess. Sorry. Q. Even a printer uses a queue principle, you know,
Yes, sir.
printer. Job scheduling, first in, first out. Even cinema tickets, first in, first out. Parsing only, yeah, parsing only uses stack. Idli container uses a LIFO. Okay. Even books, even books, if you are arranging in the library, one end is closed, one end is opened. You are
Wait, sir.
keeping the books, the last insert book is removing first. That is also
Non-linear is
LIFO. Now the answer is
graph.
parsing
Graph, sir.
expression only. Keep in mind. Next, which of the following is a non-linear data structure? Very simple. Very simple. I think you can.
Because array, let's say array A of 10, so it goes from 0 to 10, 0 to 9. Linked list also we start from 0.
No,
Stack
perfect
also we
answer.
start from
Perfect answer.
0 onwards, no sir.
Why? Can you justify?
But whereas graph, it will have edges and vertices.
Mm.
Yes, 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 sir.
Ah, it's a tree.
Algorithms can
Tree.
work on a
It is a
disconnected
tree-like a
graph.
structure.
Disconnected
Okay.
graph.
Okay.
Hmm, I think is
Next,
it
which of the following?
disconnected graph?
Tell me.
C. Answer is C.
So which of the following algorithm can work on disconnected graphs? Disconnected
Okay.
graphs.
Okay.
Disconnected graph. BFS, DFS, both perfect
Okay,
answer,
sir.
Ramchan,
Internal
because
nodes
we are
have.
using minimum spanning tree concept under that.
Uh,
Okay. So we are
so
using
in complete binary
this
tree,
one.
internal
Perfect
nodes
answer.
have
Next, in a
exactly two
complete
children.
binary tree,
Yes, sir. Exactly two children, sir.
read the question.
At two
Somebody
children.
is joining, you can allow him. No problem. Okay. In a
Yes,
complete
sir. One
binary
person joined,
tree,
sir.
internal nodes have binary tree, complete binary tree. Yes, exactly two children. That is perfect. That is perfect answer, Ramchand. Is there anybody joined? No problem. So the answer is exactly two children. Here you need to know the concept of
Okay,
binary
sir.
tree. Binary tree is a tree having at most two children. Complete binary tree is also a kind of binary tree. Exactly two children, left child and
The
right child.
function
Okay,
calling
we
itself
are
again and again
following.
for
This
many
is
times.
complete binary tree concept. Next question. Which data structure is used to implement a recursive algorithm? What
Yes,
is
sir.
meant by recursive? The function calling it's
Uh,
yes. Queue, stack, arrays, linked list.
let's say
Which data
array is
structures?
static.
These
Yeah,
four are
because we say A of
data
10.
structures.
Yeah.
Which one is a static data structure? Which one is a dynamic data structures? Now
We
tell
can
me.
expand the size depending upon the requirement.
Yes. Only array is
Yes, sir.
perfect answer. Perfect answer. Yeah. And what is the dynamic data structures?
Okay, sir.
Yes.
First,
Linked list is the best example for dynamic data structures. But our question is, which data structure is used to implement a recursive algorithm?
it's
Usually
order of
stack. Okay, what is the
order
principle of stack? Last in,
of
first out.
n.
Next question. What is the time complexity to insert an element into a stack?
Yeah.
Suppose five elements are there.
So,
You
okay,
have inserted
insertion takes only
10,
one. Okay, sir.
20, 30. If you are inserting 10, 20, 30, now for insertion, how
Typo
much time it
notation.
takes? Order of one only, because in one iteration we can insert. Okay. This is a mathematical big O
Uh,
notation. We used to call it as mathematical big O
priority.
notations. Yeah, next question. Which data structure is best suited for priority queue implementation? I have
Linked
explained
list.
already. Priority queue is a type of queue.
Heap. Okay.
Yes. Which data structure is best suited for priority queue
Okay,
implementation?
sir.
Arrays, list, binary tree, hash table, priority queue, binary heap. Heap is a complete binary tree. Keep in mind. I'm explaining. Heap is a heap is a complete binary tree concept based. We are inserting elements in
Okay,
a
sir.
tree. So left child always less than the root, right child always greater than the root. Binary heap is a best data structure for a priority queue principle. Okay. Okay, next, array is a collection of homogeneous elements and shared by a common name. Linked list is a collection of nodes and connected by the links in one direction is called a
Circular.
singly linked list. Collection of nodes and connected by the links in both direction is called a doubly linked list. Collection of nodes and connected by the links, the last node is connected to the first node is called a circular link. Binary heap, it is a complete binary tree. Hash table is a one of data structure which follows the hashing. Hashing is nothing but a process of mapping key with value. Hash table follows the indices called index positions like bucket 0 to bucket n. The searching is very fast based on the index position. That's why we are using hash table. Hash table is a collection of elements based on the index position. If two elements are competing, hold a same bucket is called collision. To avoid the collision, we are using
Yes,
collision
sir. Yes, sir.
resolution techniques called open addressing, quadratic probing, double hashing, separate chaining address. Did you remember? These are the
Um,
four collision
for
resolution
insertion,
techniques.
it is
Ramchan,
O of 1 for insertion.
perfect.
For
Next,
deletion,
in
it
a
will be
singly
O
linked
of
list,
n.
what is the time
Okay.
complexity of deleting a node? For insertion,
Yes, sir.
it is similar.
Yeah,
Yeah.
same. Yes, sir. Yeah. Yes, sir.
Because
Yes, yes.
if suppose the deleting element is last position, how many elements you have inserted? Suppose three. How much time it takes?
Right.
Order of n. Three iterations it will take. Okay. You understood?
Uh, it
Next
could
question.
be
Tell me.
log n minus n plus
Sorry.
1.
A complete binary tree with n nodes has a height of, how do you can calculate?
Mm-hmm.
Yeah, see, log n means binary search tree, n means linear
Okay,
search,
sir.
Log of n plus 1 is the perfect answer for complete binary tree. It follows the binary tree concept
In
and
the worst case scenario, what is
exactly
the time
two
complexity
children
of
must be there.
searching in a hash table?
Okay, so
So, okay.
that is called order of log n plus 1. Next question.
Yeah. Okay.
Yes. Order of n square. Why?
Okay.
Because we are sorry, order of n because the searching element
Yes.
in the last position. Still, a bucket of 0 to bucket of n, it will go worst case. So first case is order of 1. Within
Yes, sir.
index position, we are finding the element very fast.
Which
Order
the
of
search
1
algorithm
iteration
works
time
only on
complexity
sorted
takes, but
arrays.
worst case, order of n. How many elements are there? That much time it takes.
Is
That's
it
a worst case scenario, order of n. Okay?
binary search?
Next question.
Binary search, yeah.
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 Sorted arrays. Perfect. Because how can you justify the constructed binary search tree is correct? I
First
told
order,
you
yes.
while explaining the data structures concept, the constructed BST is true when we can justify the constructed tree traversal algorithms like in order, pre-order, post-order, in level order based on in order traversal. In order
Yes,
means
sir.
in means root must be in the middle, left to root to right.
Yes, sir.
In order, based on the in order principle, we are the way we are getting ascending, less to
Uh,
high. Okay, that is a ascending order. Okay, ascending order elements.
Wait, so 1 minute, sir.
Next question.
Is
Which
it
of
is
the
it
following
counting sort?
sorting
Is it
algorithms is
counting
not
sort?
a comparison sort?
Okay.
All are comparison sorts only except one.
Yes, sir.
Now, perfect. Yeah, perfect answer. Perfect answer. Selection sort uses, we are selecting a minimum element, compare with left and right elements. That's why it is a comparison sort. Merge sort also, it uses comparison sort. Bubble sort, first element compare with the next element. It's a exchange sort. We used to call it as exchange sort. Selection sort we used to call it as a min sort. Minimums, select minimum element, compare with other elements. Okay. Merge sort, merging two sorted arrays,
The type of graph
merge sort.
contains no cycles. Acyclic?
Counting sort is
No,
not
no,
a
1 minute, sir.
comparison sort. Next,
Okay,
which
correct,
type
correct.
of graph
Okay.
contains no
Yeah, yeah.
cycles?
Got
Now
it, sir.
tell
Got
me.
it. Which algorithm is most efficient in finding the shortest path in an unweighted
Yeah,
graph?
perfect answer. Yeah, I have explained already, Oh, yeah,
I
next question.
okay, yeah.
Yeah.
Yes, sir, yes.
If you are strong in data structures, nobody can defeat in this world. You will become very good programmer and very good
Unweighted graph.
computer. Faculty.
Mm,
It's a core subject. It's a core subject. Which algorithm is most efficient in finding the shortest path in an unweighted graph?
okay.
Yeah. So usually we are using breadth first search, depth first search,
It
minimum
follows like
spanning tree
Q,
concept.
Q's,
So
Q.
there are some weights are there in that graph. Which algorithm is
Okay,
most
okay, sir.
efficient in finding the
It is
shortest
optimal
path?
for
Breadth first
implementing
search.
the
Why? It uses principle called
strategy
first
against.
in Q principle. That's why
Yes,
it is the
yes.
most efficient.
Yes, sir, yes.
Okay. Which
Uh,
data structure is optimal for implementing
maybe 3 or 4. This
recently
C or
used
D. I'm not
cache?
sure,
Cache is
sir.
a memory.
Yeah.
Cache is a temporary memory.
Okay.
Now tell me, which data structure is optimal? Yeah, D. Doubly linked list with a hash table. Yes, that is correct answer. Remaining. See which data structure is optimal for implementing least recent used means. In doubly linked list concept is you can insert both ends, NQ and
Yes, sir.
DQ. NQ says that insert the element,
The order
DQ
in which
says
the
that
elements
deleting the
come
element.
off is
Both ends
the
you can insert and
the
delete.
order in which the
That is the
elements come
option
off.
for doubly linked list with the
Yeah,
hash
reverse order,
table.
sir. B.
Okay. Next concept. In a stack, tell me. Hmm.
A circular queue is also known as wait, sir. Circular queue. Can I say ring buffer?
Perfect answer, Ramchand. You understood very well about stacks concept. Next.
Which of the following is not a type of linked list? Answer D.
Hmm. Yes. Perfect answer. Next, 34.
Yeah, singly linked list
Which of the
will have
following is
a
not a type of linked list?
uh, links.
Perfect answer. You know singly linked list. How can you define? Can you
Okay, sir.
define it?
Collection of nodes connected by the links in one direction.
Collection
Singly
of
linked list.
nodes
Collection of
connected by
nodes
the
connected
links.
by
You can remember very simple. Collection of
I mean,
nodes
both the
and
directions
connected by the links in one
is called doubly
direction
linked list. Connection of nodes connected by links with both the directions, and the last
is
node
called
connecting to the first node is called
doubly
circular linked list.
links. Both is called
Okay,
perfect.
in order traversal of the nodes will result in
Perfect
order.
answer.
Answer
Next,
C.
in a binary search tree, BST.
The nodes. Yeah.
In a binary search tree, in-order traversal of the nodes will result in
Yes, sir.
perfect. Perfect answer, ascending order. I have explained already. You remembered very well, very well. How can you justify
Crop
constructed by
sequence.
binary search tree is true based on this answer? Okay?
Okay.
Perfect. Open
Okay.
addressing is also known
Okay.
as. No. Open addressing means closed hashing. It's a special concept to keep in mind.
Order of n only, sir.
Hmm. Next, what is the time complexity of a linear search algorithm in the worst
So is it
case?
order of 1?
Worst. Perfect answer. What is the best case time complexity of the
Okay.
bubble sort algorithm?
Okay.
Worst
Okay, sir.
order of one. No. In bubble
Okay, sir.
sorter, suppose the searching element is in last position. How many elements it? Suppose 5 elements. Best case also, it takes order of n only because it's
Sir,
a
what is
exchange
time
sorter. It can
complexity?
compare with all the
Okay.
elements. Okay. Next question. In a merge sort
Okay.
algorithm, what is the time complexity for
Detected
merging two
Asadi
sorted
graph.
halves?
Minimum number of
It's
vertices
a time
must be there
complexity for order of
for
n
it to
only.
contain a cycle.
Because two halves
Uh,
means two subparts. It takes order of n, same thing. Next, in a direct acyclic graph,
is it
DAG, yeah, the minimum number of vertices
okay?
means vertex, no, means nodes. Minimum. Suppose cycle means at least you need to have it cannot contain a cycle.
Okay, got it, sir.
DAG is nothing but
Okay, it is
acyclic graph,
acyclic.
na?
Okay.
So how come how many nodes? Maybe zero, maybe one, maybe two nodes. So acyclic means what? You cannot form a ring. You cannot form
Okay, sir. If it is a
a
cyclic graph, then it should be
acyclic means no connected
okay,
all
sir.
the graphs. Okay, the minimum number of vertices that must be therefore it is
Okay.
for it contain a cycle means DAG. Minimum two.
Find the shortest
Otherwise,
path in a
uh,
weighted graph.
otherwise one
Okay.
node also you can self loop. Self loop
Wait.
cycle. Okay. Next, which of the following graph traversal algorithm can be used? Find the shortest path in an unweighted. These are the special way to read cards. That is BFS only. Which are the following graph
Yes, sir.
traversal algorithm
Test out.
can be used to find the shortest path? Earlier question also similar to BFS only. Breadth first search uses a Q principle, first in, first out principle. First in, first out principle. In the quicksort algorithm, what is the time complexity in the worst case when the pivot chosen is always the smallest or largest element? Quicksort, the best sorting algorithm in a 7 sorting algorithms. Why? Because we are choosing one element in the list that is called pivot,
Okay.
any element randomly left with pivot left I with pivot, right j with pivot. At a time you are sorting the
Okay.
elements and quickly we are achieving the result. So here we are asking the time complex worst means order of n square, two loops we are using I for I with left side to pivot one for loop we are using. Right side
Yes,
j
sir.
with pivot one more for loop we are using. For one for loop order of n multiplied by one
Uh,
more for loop
it's
order
more
of
than
n.
four.
Order of n
For
multiplied
1 hour,
by
sir.
order of n,
It was very useful
what it
session
will
today.
happen? Order of n square. Yeah, with this one
Yeah.
I am closing today's
Yes,
session.
sir.
How much time is there, Ramchandra?